In this demo, we're going to show you how you can use Amazon SageMaker Ground Truth to label images, then use those labeled images to train an Amazon recognition model. The images we're going to have labeled are images of slugs and snails. Let's start by creating a new labeling job. The first thing we need to do is identify where the images are stored we want to have labeled. I've already uploaded these images to an S3 bucket. For Ground Truth to process the images, we need to add them to a manifest file. A manifest file is simply a file that contains a list of all the images in the correct format. If our images are already stored in S3, we can create a manifest by clicking the Create Manifest File. We need to feed in the location of the images in S3, then click Create. The images from the S3 bucket are added to a manifest. To use it, we need to click the Use This Manifest. Now we have the manifest identified, let's add some more info. Output location is where the labeled dataset will be stored. We need to make sure the service has permissions by selecting the correct IAM role. Next up is to decide if we're going to label the whole dataset or not. We're not going to label the whole dataset, just a sample, which we will use 20%. We might want to do this to test the effectiveness of the job before creating a large job. We're doing it because it's a demo. We have to identify the type of labeling job we want. In our demo, we want to have bounding boxes around the images. Now we can decide who can do the work. We have three choices. Mechanical Turk creates a job that is published to the Mechanical Turk marketplace. The job details and images will be visible to the contractors who take the job. Private allows you to create your own list of people who can perform the labeling. This is useful if you have the staff or the images are sensitive. Finally, there is Vendor Managed, which allows you to use a third-party vendor to perform the labeling. We're going to use Mechanical Turk, and based upon the complexity of the task we're asking them to perform, we can select pricing. We need to confirm this dataset does not contain adult content and accept the confirmation about using Mechanical Turk. Mechanical Turk is going to provide a UI for labelers. We need to ensure we put the instructions in the UI that can be followed by the contractor. You should include examples of good and bad labeling so the contractor can see what is expected. The better the instructions, the more likely the contractor will perform the task correctly. We can see what the tool looks like by clicking Preview. This is the labeling tool that Mechanical Turk workers will see. We can see how instructions are displayed and even draw a bounding box to test. There are tools to undo, zoom in, etc. And once we're done testing, we can close the window. Now that we've defined the job, let's start it. Here's our job in progress. It takes some time for this to complete as the job needs to be published and humans need to complete the work. So let's wait a bit and come back later. Here are the results of the job. You can see the information about the job along with the labeled images. You might notice that images may not be labeled correctly. This might be a good time to update the instructions and rerun the job, or we can fix them later. Let's use this labeled dataset to train Amazon recognition. This is Amazon recognition custom labels. We have to create a new project. We need to add a dataset for training and test. We will import our images from Ground Truth. We need to give our dataset a name. We can enter the path to the output manifest, which we can grab from the Ground Truth job. To make sure recognition has the right permissions to the bucket, we can copy the bucket policy from this screen. To this S3 bucket policy. Now we can view the labeled images. We can also fix and tweak any of the labeling. You can see this image has been incorrectly labeled. It has been labeled for both a slug and a snail. Let's fix that. I went ahead and fixed the other images off camera. Now let's figure out the test set. We're going to use some images to train the model, but we will hold some back for testing. If we already have the training test split, we can choose that. Otherwise, we can select Split Training Set, which is going to split the data set into 80% for training and 20% for testing. Now recognition is going to train the model, and we need to wait for it to complete. It doesn't take very long. Once the model training is complete, the test data is used to calculate some metrics. Precision is the proportion of results that were correctly identified in the training set. You can see for slug it's 95% and snail is 87%. Recall is the percent of positive identifications. You can see this is 65% for both, not terribly great. Assumed threshold was the probability used to positively identify the image for a slug or snail, and the F1 score combines the recall and precision together. Here you can view the results of the test. Many images have false positives. To improve the results, we might want to increase the number of training images and make sure they are correctly labeled. To host the model, we need an application. There's a test application available in GitHub that you can deploy to your AWS account and use. This is the UI to perform the prediction. We need to upload an image. And if the model detects a slug or a snail, the confidence score is returned along with the bounding box coordinates, which we can use to draw a box. In this demo, you saw how you can use Amazon SageMaker Ground Truth to create a job to label images using Mechanical Turk. You then saw how to use the results of that training job to create an Amazon Recognition custom labels job. Finally, you saw how you can use the sample app to test the predictions. That's it for this demo.
It's now time to summarize some of the main points in this module. In this module, you learned how to describe the use cases for computer vision, describe the Amazon Managed Machine Learning services available for image and video analysis, list the steps required to prepare a custom dataset for object detection, describe how Amazon SageMaker Ground Truth can be used to prepare a custom dataset, and use Amazon Recognition to perform facial detection. That concludes this introduction to computer vision. Thanks for watching. We'll see you again in the next video. Hi, and welcome to Module 6 of AWS Academy Machine Learning, Introduction to Natural Language Processing. In this module, we'll introduce natural language processing, which is also known as NLP. This section includes a description of the major challenges faced by NLP and the overall development process for NLP applications. We'll then review 5 AWS services you can use to speed up the development of NLP-based applications. After completing this module, you should be able to describe the NLP use cases that are solved by using managed Amazon ML services, and describe the managed Amazon ML services available for NLP. Let's get started. We'll get started by reviewing what natural language processing means. Natural language processing is also known as NLP. Before we explain what NLP is, we'll consider an example of NLP, Amazon Alexa. Alexa works by having a device, such as an Amazon Echo, record your words. The recording of your speech is sent to Amazon servers to be analyzed more efficiently. Amazon breaks down your phrase into individual sounds. Then, it connects to a database containing the pronunciation of various words to find which words most closely correspond to the combination of individual sounds. Amazon identifies important words to make sense of the tasks and carry out corresponding functions. For instance, if Alexa notices words like outside or temperature, it will open the Weather Alexa skill. Amazon servers then send the information back to your device and Alexa speaks. NLP is a broad term for a general set of business or computational problems you can solve with machine learning, or ML. However, NLP systems predate machine learning. For example, speech-to-text on older pre-smartphone cell phones used NLP, and so did screen readers. Many NLP systems now use some form of machine learning. NLP considers the hierarchical structure of language. Words are at the lowest layer in a hierarchy. A group of words make a phrase. In the next level up, phrases make a sentence. And ultimately, sentences convey ideas. NLP systems face several significant challenges. We'll look at its challenges next. Language isn't precise. Words can have different meanings based on the other words that surround them. This is known as context. Often the same words or phrases can have multiple meanings. For example, consider the term weather. You could be under the weather, which has a colloquial meaning in English that you're sick. Or you could say, there's wonderful weather outside, which means the weather conditions outside are good. The phrase, oh really, could convey surprise, disagreement, and many other things. It depends on the context and inflection. Here are some of the main challenges for NLP. One challenge is discovering the structure of the text. One of the first tasks of any NLP application is to break down the text into meaningful units, such as words, phrases, and sentences. Another challenge is labeling data. After the system converts the text to data, it must apply labels representing the various parts of speech. Every language will require a different labeling scheme to match the language's grammar. NLP also faces a challenge in representing context. Because word meaning can depend heavily on context, any NLP system needs a way to represent it. This is a large challenge because there are many contexts, and it's difficult to convert context into a form computers can understand. Finally, although grammar defines a structure for language, the application of grammar is indescribably large in scope. Handling the variation in how language is used by humans is a major challenge for NLP systems. That's where machine learning can have a large impact. You can apply NLP to a range of problems. Some of the more common applications include search applications, such as Google or Bing, human-machine interactions, like Alexa, sentiment analysis for marketing or political campaigns, social research based on media analysis, and chatbots to mimic human speech in applications. You can apply the machine learning development pipeline you've seen throughout this course when developing an NLP solution. The first task is to formulate a problem, then collect and label data. For NLP, collecting data consists of breaking down the text into meaningful subsets and labeling the sets. Feature engineering is a major part of NLP applications. This process gets complicated when you're dealing with highly irregular or unstructured text. For example, say you're building an application to classify documents. You'd need to be able to distinguish between the words with common terms but different meanings. Labeling data in the NLP domain is sometimes also called tagging. In the labeling process, you assign individual text strings to different parts of speech. There are specialized tools you can use for NLP labeling. The first task for an NLP application is to convert the text to data so it can be analyzed. You convert text by removing words that aren't needed for analysis from the input text. In the example, the words this and is are removed to leave the phrase sample text. After removing stop words, you can normalize text by converting similar words into a common form. For example, the words run, runner, ran, and running are all different forms of the word run. You can normalize all instances of these words in a block of text using the stemming and lemmatization processes. Lemmatization groups different forms of a word into a single term. lemmatization of the versions of the word run would group all instances of those forms into a single term, run. Stemming, on the other hand, removes characters that the stemming algorithm considers unnecessary. Stemming might not work with the run example, as the form ran might not be recognized as a form of the word run. After you've normalized the text, you can standardize it by removing words that aren't in the dictionary you're using for analysis. For example, you could remove acronyms, slang, and special characters. The Natural Language Toolkit is also known as NLTK. Their Python library provides functions for removing stop words and normalizing text. Another first step in creating an NLP system is to convert the text into a data collection, such as a data frame. All NLP libraries provide functions to assist with this process. The example shows using the word tokenize function from the NLTK library. After you've cleaned up your text and loaded it into a data frame, you can apply one of the NLP models to create features. Here are a couple of common models. The first model is known as bag of words. This is a simple model for capturing the frequency of words in a document. The model creates a key for each word. The value of the key is the number of times that word occurs in the document. The second model is term frequency and inverse document frequency, which is also known as TF-IDF. Term frequency is a count of how many times a word appears in a document. Inverse document frequency is the number of times a word occurs in a group of documents. These two values are used together to calculate a weight for the words. Words that frequently appear in many documents have a lower weight. There are many established models in the NLP field. The example shows a bag of words model. Bag of words is a vector model. Vector models convert each sentence or phrase into a vector, which is a mathematical object that records both directionality and magnitude. In the example, a simple sentence is converted into a vector, where the frequency of each word is recorded. The word is has a value of 2 because it appears twice in the sentence. Bag of words is often used to classify documents into different categories. It's also used to derive attributes that feed into NLP applications, such as in sentiment analysis. There are 3 broad categories of text analysis. First, the classification of text is similar to other classification systems you've seen in this course. Text provides the input to a process that extracts features. Then you send the features through a machine learning algorithm that interacts with a classifier model and infers the classification. There are many applications for text matching. For example, autocorrect spelling and grammar checking are based on text matching. The algorithm for edit distance, also known as the Levenshtein distance, is frequently used. You can derive relationships between different words or phrases in the text using a process called co-reference resolution. Several NLP systems provide Python libraries for deriving relationships. One of the biggest challenges for NLP is how to describe the context for the text. Consider this example, where a user is searching for the term tablet. Because the word tablet has at least 2 distinct meanings, the search engine needs to know which meaning the user has in mind. Most search engines rely on the most commonly used context, if the term isn't qualified further. For example, by adding another term like medicine or computing to the search. The process of extracting entities is known as named entity recognition, or NER. An NER model has the following functions. First, it can identify noun phrases using dependency charts and part-of-speech tagging. It can classify phrases using a classification algorithm, such as word2vec. Finally, it can disambiguate entities using a knowledge graph. Here's an example of using NER to extract the entities Titanic and North Atlantic from the text. After the named entities are extracted, you can use a knowledge graph to extract meaning. A knowledge graph combines subject matter expertise with machine learning to derive meaning. The Amazon recommendations engine is an example of a knowledge graph. Here are the main points to remember from this section. First, NLP predates machine learning. You can use the same ML workflow that you've seen in other modules for NLP. Some of the main use cases for NLP are search query analysis, human-machine interaction, and marketing and social research. NLP is complicated because human language lacks precision. Thanks for watching. We'll see you in the next video. Welcome back. In this section, we'll review 5 managed machine learning services you can use for various use cases. These services simplify the process of creating a machine learning application. We'll start by looking at Amazon Transcribe. You can use Amazon Transcribe to recognize speech in audio files and produce a transcription. It can recognize specific voices in an audio file, and you can create a customized vocabulary for terms that are specialized for a particular domain. You can also add a transcription service to your applications by integrating with WebSockets, an internet protocol you can use for two-way communication between an application and Amazon Transcribe. Here are some of the more common use cases for Amazon Transcribe. First, medical professionals can record their notes, and Amazon Transcribe can capture their spoken notes as text. Also, video production organizations can generate subtitles automatically from video. This could also be done in real time for a live feed to add closed captioning. Media companies can use Amazon Transcribe to capture and label content. They can then feed the content into Amazon Comprehend for further analysis. Last, companies can record customer service or sales calls and transcribe them. They can analyze the results for training or for strategic opportunities. Amazon Polly can convert text into lifelike speech. You can input either plain text files or a file that's formatted in Speech Synthesis Markup Language or SSML. SSML is a markup language used to provide special instructions for how speech should sound. For example, if you want to introduce a pause in the flow of speech, you can add an SSML tag that instructs Amazon Polly to pause between two words. You can also output speech from Amazon Polly to MP3, Vorbis, and PCM audio stream formats. Amazon Polly is eligible for use with certain regulated workloads. For example, it's eligible for use with the U.S. Health Insurance Portability and Accountability Act of 1996, or HIPAA. Amazon Polly is also eligible for use with Payment Card Industry Data Security Standard, or PCI DSS. Here are some of the more common use cases for Amazon Polly. As a first example, major news companies are using Amazon Polly to generate vocal content directly from their written stories. It's also been embedded in mapping APIs, so developers can add voice to their geo-based applications. Language training companies have used Amazon Polly to create systems for learning a new language. Finally, animators have used it to add voices to their characters. With Amazon Translate, you can create multi-language experiences in your applications. You can create systems that read documents in one language and then render or store them in another language. You can also use it as part of a document analysis system. Amazon Translate is fully integrated with other machine learning services, such as Amazon Comprehend, Amazon Transcribe, and Amazon Polly. With this integration, you can extract named entities, sentiment, and key phrases by integrating it with Amazon Comprehend, create multilingual subtitles with Amazon Transcribe, and speak translated content with Amazon Polly. Here are some of the more common use cases for Amazon Translate. The first use case is building international websites. you can use Amazon Translate to quickly globalize your websites. Amazon Translate can also be used to develop multilingual chatbots. Chatbots are used to create a more human-like interface to applications. With Amazon Translate, you can create a chatbot that speaks multiple languages. Another use case is software localization. Localization is a major cost for all software aimed at a global audience. Amazon Translate can decrease software development time and significantly reduce costs for localizing software. The final example use case is international media management. Companies that manage media for a global audience have used Amazon Translate to reduce their costs for localization. Amazon Comprehend implements many of the NLP techniques that we reviewed earlier in this module. You can extract key entities, perform sentiment analysis, and tag words with parts of speech. Here are some of the more common use cases for Amazon Comprehend. The first example is analyzing legal and medical documents. Legal, insurance, and medical organizations have used Amazon Comprehend to perform many of the NLP functions we reviewed in this module. Another use is for large-scale mobile app analysis. Mobile app developers use Amazon Comprehend to look for patterns of usage with their apps so they can design improvements. Financial fraud detection is another use case for Amazon Comprehend. Banking, financial, and other institutions have used it to examine very large data sets of financial transactions to uncover fraud and look for patterns of illegal transactions. Finally, it can be used for content management. Media and other content companies can use Amazon Comprehend to tag content for analysis and management. With Amazon Lex, you can add a human language front end to your applications. Amazon Lex lets you use the same conversational engine that powers Amazon Alexa. You can automatically increase capacity for your Amazon Lex solution by creating AWS Lambda functions that scale on demand. You can also store log files of the conversations for further analysis. Here are some of the more common use cases for Amazon Lex. The first use case is building front-end interfaces for inventory management and sales. Voice interfaces are becoming more common. Companies have used Amazon Lex to add chatbots to their inventory and sales applications. Another use for Amazon Lex is creating customer service interfaces. Human-like voice applications are quickly becoming the standard for many customer service applications. Amazon Lex can reduce the time it takes to develop these chatbots and increase their quality. Amazon Lex can also be used to develop interactive assistants. By combining Amazon Lex with other ML services, customers are creating more sophisticated assistants for many different industries. The final example use case is querying databases with a human-like language. Amazon Lex has been combined with other AWS database services to create sophisticated data analysis applications with a human-like language interface. Here are some of the main points you should take away from this module. First, Amazon Transcribe can automatically convert spoken language to text. Amazon Poly can convert written text to spoken language. Amazon Translate can create real-time translation between languages. Amazon Comprehend automates many of the NLP use cases reviewed in this module. And finally, Amazon Lex can create a human-like interface to your applications. Thanks for watching. We'll see you in the next video.